So in our last video, we had a look at a whole bunch of different index laws. In this one, we're going to be focusing just on what they call the negative index. And that's focusing on having powers which have got negative numbers on them. So we'll have a look at two quick examples here, then we'll move on to something more complicated. Now the first one we've got here is a to the power of minus m is equal to 1 over a to the power of m. And I'll just show you how we can quickly prove that. What we've got is example 1 here. We're going to look at x to the power of 5 over x squared, or x to the power of 2. Now we could rewrite that as x to the power of 5 divided by x to the power of 2. It's the same thing. And that last video, we saw that when we're doing something like this, we can just rewrite it as this x to the power of 5 minus 2, and we get x to the power of 3. So how do we get this? How do we get that little law there? Well, what we do is we can rewrite it out in its simplest form. We'll expand it out. So we've got 5 x's all multiplying together on that numerator there. And on the bottom we've got x squared, or x times x. So I've put that on the denominator. Now if we cancel out every x, one on the top, one on the bottom, then we're only left with 3 x's there on the top. So we end up getting x cubed. Now, second example will show you how the negative index works. If, for example, I was to write x squared over x to the power of 5 instead, well, that's simply going to be x squared divided by x to the power of 5. And we could rewrite that in a similar way that we wrote it in that first example where we had 5 take away 2. Well, in this case, it's going to be 2 take away 5. And we know that 2 take away 5 is going to give you x to the power of minus 3. So if I just expand this out, what we're going to get is this. And cancelling out our x's, we're left with no x's on top. So what I'm going to do is just put 1 there. And on the bottom we've got 3 x's multiplying together. So you can see here that these must be equivalent answers. These must be exactly the same answer, except one says x to the power of minus 3, and the other one, which is the same answer, is written as 1 over x to the power of 3. So these things are exactly the same, and you can see that that's how we get our negative index rule here. This very first one, it says that if you've got something to the power of negative m, then placing that same thing on the denominator would make it a positive power. Instead of negative m, it becomes positive m. You can see the same things happened here. We've got x to the power of minus 3. Well, if I go and move that to the denominator, what we're going to get is 1 over x to the power of positive 3. So let's take this a little bit further. So for example number 3 here, we want to express this fraction with a positive indices. So we've got 1 over x to the power of minus 3. We want to get rid of that minus in there. So if you have a look at this rule here, we've got 1 over a to the power of minus m simply becomes a to the power of positive m. So we get rid of the fraction, and we also get rid of the negative index there. So we could rewrite this straight away and say it's simply going to be x cubed. But why does that happen? You don't want to have to remember all of these little rules. So we can do it this way. What we could do is say 1 over x to the power of minus 3. Well, 1 over can also be written as 1 divided by x to the power of minus 3. And we could also rewrite this again. What we now know is that these negative indices can be rewritten like this. We've got 1 divided by 1 over x to the power of positive 3. That's what we just did in that last example. Now we've got 1 divided by 1 over x to the power of positive 3. 1 over here can be rewritten as 1 over 1. So now you've got two fractions. One is dividing the other one. Now what can we do with divided by and fractions? What we can do is make this into a multiple and flip that second fraction. So what we're going to do is make this 1 over 1 times, and this flips over, we've got x cubed over 1. So if you just times the top, we get x cubed over 1, and that's simply x cubed there. So let's take a quick look at these three examples here before we go any further. I want to express all of these as positive indices, so I want to remove anything like these negative powers that we've got here, here, and here. So what I'm going to do first of all is just turn this one straight away. We now know that that's 1 over m to the power of 5. So that there is done already. Now this one here is a little bit tougher, but we just expand it out. See what we've got here. We've got 2 multiplied by, that's p to the power of minus 2, and then we've got multiplied by q to the power of 3. Now we can also rewrite this as 2 multiplied by, now p to the power of minus 2, well, that's simply going to be 1 over p to the power of positive 2. And then we're multiplying that by q to the power of 3. Now, if you want, you could take each of these values over here and also express them as fractions. So we've got 2, that's also 2 over 1. And q to the power of 3 can be rewritten as q to the power of 3 over 1. So we're just going to be multiplying the top with the bottoms there. So we've got 2 times 1 times q to the power of 3. So we end up with 2 q to the power of 3. And on the bottom, we've just got 1 times p squared times 1. So it's just going to be p squared there. There's your final answer. And you'll find that you can quickly move these around without having to go through all of that there. You'll see that you've got p to the power of minus 2, just bring it straight to the bottom there. But that just shows you how that works. So for our last one, we've got 7 over t to the power of minus 2. Well, that's simply going to be 7 multiplied by 1 over t to the power of minus 2. And we now know that we can rewrite that with a positive index on the top there. So I'll just make that 7 multiplied by t squared. So you get 7t squared as your answer. So for this example here, we're trying to get rid of that negative index, and we're going to simplify it as well if we can. So what we've got, if we have a look here at this rule, indicates that if you've got a negative power outside of these brackets, then you can flip the fraction on the inside and make that power positive. So if I flip this, what we end up with is c to the power of 6 becomes c to the power of 6 on top, and c cubed goes on the bottom, and then we get 2 on the bottom as well, and that's all getting powered by 4. Now, if you ever think about what happens to that 4 there, it's going to multiply onto each of these powers. There's a power of 1 there for the 2 as well. So if you think about that rule we used in that last video, we had a to the power of m all powered by n on the outside of those brackets. What happened with that? We always did this. We had a to the power of m times n. So over here, that 4 is going to multiply onto every one of these powers. So you end up with this. You get c to the power of 6 times 4. I'll rewrite it like this. 6 times 4 over here, you get 2 to the power of 1 times 4. And here you get c to the power of 3 times 4. So you end up with 6, 12, 18, 24 powers of c on top. On the bottom you get 2 to the power of 4, and you get c to the power of 12 on the bottom. So what we're going to do is subtract 12 from 24, because that rule we learnt in the last video was a to the power of m over a to the power of n is equal to a to the power of m minus n. So really what we've got here is c to the power of 24 minus 12 all over 2 to the power of 4. And finally, 24 take away 12, that's going to give you c to the power of 12. And 2 to the power of 4, that means 2 times 2 times 2 times 2, so you get 16 as your final answer. Now if you find you don't like remembering all these rules, you've got to have done this a completely different way. Another way of doing this is this. We've got a to the power of m, all to the power of n is m times n. You can see that taking place here. So this minus 4 is going to be multiplying onto every power inside these brackets, and 2 is 2 to the power of 1. So you could rewrite it like this. You've got 2 to the power of 1 times negative 4. That minus 4 is going to multiply onto that there. The same thing happens here with c to the power of 3 multiplied by negative 4. And that's all over c to the power of 6 multiplied by negative 4. If we rewrite that, we get 2 to the power of negative 4, and then we've got here c to the power of negative 12, all over 6 times 4 is negative 24, c to the power of negative 24. Now we could take that one step further as well using this rule here. We've got a to the power of m over a to the power of n is a to the power of m minus n. So you're going to take away that n from the index on the top. So the index on top is c to the power of minus 12. We're going to be subtracting negative 24. So I'll rewrite 2 to the power of minus 4 first. We've got 2 to the minus 4. And here we've got c to the minus 12. And it says here we take the top and subtract the bottom. So what's on the bottom? We've got minus 24. So I'm going to subtract the bottom. Subtracting minus 24. So here we've got 2 minuses. What do 2 minuses become? Well, we get this. We get 2 to the power of negative 4, then c to the minus 12, and a minus and a minus is a plus. So you get plus 24. So minus 12 plus 24 is going to give you positive 12. So that negative 4, I'm just going to put that in the bottom straight away. We get 2 to the power of positive 4. And on top we've got c to the power of 12 now. Finally we get c to the power of 12, and 2 to the power of 4 is 16. So same answer, either way you go.